So what's your status again? Sorry.
We are stuck only on the last step, the third step. We noticed that even in the tutorial, when we plot the visits graph, it shows different behavior than what's in the slides. So we believe that there is something wrong with the files for step 3.
Okay, could you please show your screen so let's
sure.
see what's exactly
Share screen. Host disabled participant screen sharing.
Oh, okay, I see. Yeah, I need to give that permission. Yeah, it should be okay now. Please go ahead.
Share screen. Okay. Is it sharing right now?
Yes, it shows up. Great. Yeah.
Yeah. When I go to the example, the solved example, and let me get a file to plot it first. Let's see. Solved example. And this is the plot we get from it, the solved example, which is different than what's in the slide.
So this wait 1 second. Let me see your screen. It's from the project 3 production example output. So this output directly, right?
Yeah.
And what your plot is what do you got? Okay, it's different. Yes.
It's different than what it should be in the slides.
What I missed here.
But when I do my own steps and plot it, I get 1 second, input files. This is my plot with my data. It becomes like this.
Yeah, it's very different.
Yeah.
Maybe it's more or less if you make have it's more or less is minus, right? Yeah, it's surprise. Yeah.
Even for the first step, it's I got it a bit different, but it was a bit more reasonable. Do you want me to show you?
Yeah, could you please what do I say? Your C is do have such sense. Okay, this is reasonable. This because the figure you're showing, I think very reasonable and it's right because you will see the x-axis is the order parameter and y-axis is the counting. So you have 10 million counting. So the total is 43. I think it's 430 counting. So each will be 43 counting. Could you please show me this configuration? I mean the
config file for this
config file, yes.
For this plot?
Yes.
Wait 1 second, where is it? Yeah, this is it.
This config, I mean the control, sorry. Control.
Control.
It should be the same. You do not need to do anything, right?
Yeah. This is the control. I did as was described, put this to 0.1 and add this command. And this is my parameter.
Your temperature and pressure, okay, I understand that part. Okay. There's no obvious arrow. So you say, okay. Why your plot is very different? Yeah. Can I see your step 2? Did you get the
step 2? Yeah.
Yeah.
1 second. It was bias generation. I did it here. Do you want the plot, right? which plot of step 2 do you want? The visits?
Yeah. Just 3, right? You do one by one after another.
Yeah, this is the visit.
Yeah, this a little weird. Yeah, this a little weird. Yeah.
It shouldn't be like this.
Yeah, this 1 year have also 1 million. How many steps here? Okay, could you go to another? This is for.
This is visits versus steps plot.
Okay, this visits all will be similar, and it should be. It looks a little different. Yeah. So please go ahead. So another order parameters.
Order parameters plot. This is it.
Okay, this is reasonable. This looks reasonable. Okay, then another.
The last one. This is it.
Yeah, this one is a little bit weird too. Yeah.
Doctor.
Yes, please.
Can we have better understanding for these figures? Because when I see them and when I see other people's figures with changing pressure and temperature, I'm not understanding what's changing and why in these figures and what does it mean. So can we have a better understanding while we are having these figures or while we are seeing them?
All right, the basic is if you have different parameters, you will have different order parameters. So the system will be your order parameters will be little different. You will see this one. If you go to change the parameters, you will have different range. So in the step 1, you will check the range. Then the step 2, you will adopt. You will change. The original one is -15 to 15, but you need to change that according to your preliminary simulation. So we should go to the step 1 to see what's your parameter range. Then you need to change that range. That's crucial. Yeah. Could you? Yeah. For example, for this example, please go back to step 1 to see.
Step 1.
You have the preliminary inputs. You will have the parameter.
You want the energy?
Let's say energy first. If you get the equilibration. This energy equilibration, do you think, I'm not sure, it's better a little bit further, right? So let's see. So how do you check, okay, this one, how many steps you have going is 300K, so 0.3 million. So more or less is around 0.3 million. It should be okay. Yeah, it's fluctuation, but later fluctuation becomes larger, right? Let's assume it's okay. Could you show me the order? Yeah, order parameters.
Yeah, this is it.
So this is 0 to -8. So you're more or less you can do from 0 to -10. Or yeah, this phase 1. Let's go to phase 2 to see.
Phase 2.
You can change the parameter 0 to 10 instead of 15. You see. Yeah.
Okay. This is phase 2 plot.
Yeah, phase 2. You will see, okay, from 0 to 10, you will see. So your order parameter will be a little bit different if you change the parameter. Yeah. That's the key. Yeah. So you do not need 15. Yeah.
So if I change these parameters, this graph will also change because it will be to 10, but
Yeah, to 10, but it should be okay. If it goes to 15, it's already covered the 10, so it should be fine. But the output, okay, the consequence is your sampling is not, sometimes is not efficient. That's why you may have some flat band. Yeah, that's some of them that's not efficient. I have not seen this before because I have not testing. Say, for example, although we already know all the parameters within plus minus 10, if you go to plus minus 100, I've never tested such case before because I think that's useless. Yeah, but for your case, you do range larger than the space itself. So some of the space, for example, is sampling beyond the 10. That's useless. I see. Yeah.
So do I need to redo the simulations at 10? Or
Yeah,
is it
could you
enough?
please do it around 10? Then maybe your C you will have much better plots. Yeah, much better results.
Okay.
Instead of in that case, you will have the 10 good shape. Instead, right now you only have 2 or 3. If you look at that, yeah. So the first step is very fast. I think it's because it's only about 1 million. If you guys for the step 1, you goes to 1 million, then you get a much better range. If you go to 0.3 million, more or less it's okay, but it's a little bit safe to go to 1 million. Yeah.
Okay.
You will see your range, right? You will see your order number is changed from parameter to parameter, right? Then later you will see, okay, what's a good range for the parameters? Then the step 2 to do the sampling around that range only.
Okay, so I go to step 1 and get a better range. Then I take that range and do step 2 and 3, and it should work fine, right?
Yes. By the way, you're a master or undergraduate?
Undergraduate concentration.
Undergraduate, okay. You know that we already extend the deadline to the 2022, right?
I think so, yeah.
Yeah, I forgot it's 22. Oh, I mean this next
12,
Saturday.
12. Yeah, 12, not.
Yeah, something. I need
last question, Doctor, just to make sure. The only things that I need to change in the files are the epsilon and sigma and temperature and pressure. The rest should be the same.
Once you change that, you will find your order number range change. Then you need to do a little bit. That's a little bit trick. Another thing you need to understand and being figure out. In the tutorial file, you should use the example output. All right, the files from example output. Then copy files into your as your original. Then you do the modification. Otherwise, you also will have some issues.
And for step 3, we need to copy the file from bias. That is, I think it's called. 1 second. fed.000 underscore 010, right? And change the name of it, right?
There are 2 ways to do that. One, you can do that, and another you can do direct simulation. So both ways, if you redo the simulation, it will take from my side, it take about 3 hours. So then you can do it. Actually, I have not to do another one. The copy is back. Maybe you can do you can do that. I need to double check that. All right. So
because this is what I've seen in the tutorial website.
Okay. So what's the I think if you follow the steps, you should be fine. What do you find is anything wrong or is anything? Otherwise, I think I will assume you're doing good. Yeah.
I did the steps exactly as they said, but I used 15 rather than 10. I will try to do it at 10 and see what will happen. And also, I've noticed something in the tutorials. The graph for energy for step 1 is different than what's in the slides. Also, let me show you.
Okay. The shape should be the same. The number will be different because you're using parameters. Yeah.
No, actually, even the shape is a bit different. Tutorial 7.
Okay. So you mean even the step 1?
Yeah.
Okay.
Here, energy. Not. Let me take volume and change. Let me take a file that I already wrote the code in.
Yeah, it's okay.
Preliminary 1, input file, energy, copy it, go to 7, solution, preliminary 1, not input file, this one, paste it here. I copied the wrong file. The thing is, it was different. I changed it by mistake right now, but it was different than what's in the slides. The graph itself, it was similar to when I run the simulation. It was similar to this one, not the one in the slides.
You should be fine because step 1 is just make the equilibration to get the range of the parameter, and then it's we already done that before. That's an NPT example. So it's an NPT example. So you do the equilibration. You need to clearly show the system become equilibrated, and you will see your statistics, your data should be valid only after equilibration. Yeah, just make in mind, right?
Okay, thank you, Doctor. I got it right now.
Yeah. The step 1 is quite simple. As our first, project 1, we do NPT example. So we already assigned you the temperature and the pressure. So you just do the NPT. You will see the volume even changes. I think if you may also look at the volume. Yeah. You already have the volume data.
Okay. Thank you, Doctor.
Yeah. Also, please, if you have something weird, you should test your change a little bit parameters to have a good equilibration, and then use that for the other steps. I think you guys still have about 1 week, so you should polish your data, and hope in the middle I will give you another half session. So I hope all of you get a good data and good scores. All right.
Doctor, for the MX, when should we submit the project?
Wait 1 second. Let me double check. So I extend the deadline to 12. So I do not want you guys have a panic. All right. So I extend the deadline to 12. But I appreciate if you guys can finish it sooner. But I know you guys have other courses. So I don't want to push you. Say okay, you have not do it in time and turn in your project, and I grade you, give you a better score. I don't want to do that. All right. I hope you guys have a good score. So right now I give your extended deadline to 12. So you can take a little bit of time and do your good in your project. Right.
Assalamu alaikum.
Yeah. Alaikum salam.
Doctor, I'm sorry for interrupting, but I have a question and I don't have time. Is it okay to plot all the data in the Excel, or should I use Python?
Okay, as I said, Python is a tool. If you use Excel or other ones, it's fine, right? We just say you plot it should be fine. All right. I just tell you, if you are knowing Python, that will make your life easier. this is a way to ask you to know a little bit about Python. Yeah, you are encouraged to use Python, but if you say, okay, currently I can do in another way, it's fine. But in the long run, from my experience, if you know Python well, it will be easier for your, for your other projects. And yeah, I hope you guys benefit from the project.
Yes, but my major is industrial engineering, and we took a whole course about Excel, so it's pretty easier for me to use Excel. That's my point. I just want to
Okay, it's
clarify.
fine. Yeah, it's fine. Yeah.
Okay, thank you, Doctor.
Yeah. That's why in your report, you do not need to I just show your final plot, right? I did that. Yeah, it's optional to include your scripts, all right? Just this way encourage you, because in other courses and eventually later Python will be more and more popular. So it will be good for you guys to learn this Python as a practice. Eventually you are good at Python, then make life much easier. Yeah, Ahmed, please go ahead if you have a question. Yeah, other questions? Yeah, Abdulhani, yeah, please go ahead.
I have a question about some figures that include this.
Yeah, please, could you please share your screen? I think you mentioned in the class, yeah.
Yes. Okay. This figure.
Yeah, I see. So your visit is a little bit different from, it's a little bit weird. Yeah, a few of them are good, but others are not good. Yeah. You see.
I didn't have bloated.
Yeah.
And that
I see.
My y-axis is not as the same as.
Yeah. And your x-axis, y is from -8 to 8.
Y-axis here.
Yeah, that's a little bit weird. Yeah. Could you please show me, because maybe this issue related to the parameter range. Could you please show me your step one? From step one, you will maybe see your range. Okay. Okay. Let's see. This step one energy. I can see a 0.3 million here.
Order parameter.
0.3 million MC steps. We have the energy. Yeah,
it's not energy, doctor. This is the order parameter.
No. Oh, this not energy. This.
No, it is just
order parameter.
Yes.
Yeah.
It is up to -8. So I have put my in the control file here. I have specified that my range is from 8 to -8.
Okay. This sounds good. This is for step 2, right?
Yes.
Okay. This step 2 and yeah. So what's the step 2? Let's see your order parameter plots should be very uniform.
Order parameter plot for.
Yeah. In the step 2, you will have parameter worth. Yeah, you have the visit.
This one.
You have the visit with order parameter.
Do you mean this one, doctor?
So this.
Or this one?
Yeah. This one should more reasonable. Yeah. So you will see in our example simulation, you have the MC steps and the order parameters. So to see is had be example evenly.
Just I will plot it now.
Okay, should be fine. And
It seems that from Ubuntu I didn't yet.
yeah, it's very quite easy. So. So you do the simulation while your own notebook, right?
Yes, I've done the same.
Cool.
Talk to maybe the production. This is the other parameter.
Okay, it's plus minus 8 plus 8 sounds quite reasonable. Quite reasonable, yeah. In your plot, you should use dot. You don't use 9. All right. So you're in your script, right? Go to 922. 922. Yeah, you use dot, not just dot. Yeah, just one dot. Do not use 9, right? It's
Like this.
R dot. Yeah.
R.
Yeah, R. Yeah. Then you're running again. Okay. Yeah, because this time you will see it's still good. It's still good.
Yeah.
Yeah, it's still good. You know, because this points is random, so it's no reason to connect them because they are not aligned, right? So this, yeah. So it's good.
Yeah. Okay, it is good.
Yeah, parameter looks good. Yeah, parameters looks good.
Problem here, doctor. The order parameter, the visits appears.
But in sense you're using different parameters, right? I'm not sure why, but in sense, all right, from your plots, I can tell it have more beyond 8. It's more or less like that. So I'm not sure why.
The problem, doctor, here, as I said, the y-axis here is using something different. I didn't know.
Yeah, it's different.
The scale here is different. It's pretty different than the scale that Python shows me when I use it.
It's quite a puzzle to me. Yeah.
Doctor, I believe this is for bias and for feedback. You have 3 columns. The first and third is for visits, which will show a figure like this one, and column 1 and 2 for bias, which is like the figure in the shared screen.
Could you please demo? This is important. Sounds important. Yeah, could you please demo?
I cannot demo. I'm using my phone right now. But yes, what I believe is he's using the second column. So he got the base figure, which is the exact for in the tutorial. I don't know. I'm not sure, but
Okay.
When I saw it, I thought it's a base figure, and it's by taking the first and second column in VDAT.
Okay.
So if you go to the project file or the tutorial, you'll see that it's base, which he got very close to the tutorials.
Okay. Could you please just follow the the ideas to have a look?
So if he used the code, the exact code that he got, but he replaces the name with VDAT. So
I'm in here.
yes, and you take okay, you got the exact one that I got, and instead of one, you put two.
Here.
Yes. For all of them.
Okay, I see your point.
So you get a visit, but I don't know if it's the right one or not.
Okay, I got it now.
So instead of gathering all the information, you only use VDAT as column 0 and 2 or column 0 and 1 for base.
Them in here. I should collect this column. Okay, thank you, Abdullah. I believe.
You're welcome.
Yeah, thank you. It's very clear. Yeah, you should this BIOS here should not be in the plot, and they just use that. Yeah, thank you.
So that's for all the visits picture or graphs. I should use the second column, not the first one.
Yeah.
But still, Doctor, the y-axis is not as it is.
Could you please just plot starting from one maybe you can check, right? You just plot 1 or 2 to see which one doesn't show a good plot, right?
What, Doctor? I didn't. Can you repeat?
Yeah. So for example, you comment all the others. Just plot the last line, right? And maybe you just plot D, for example, right?
D.
Yeah, you just plot a D, right? Just plot 1, yeah. And all others, you just comment, right? Yeah. Just give you an example, all right? So run it. So you will see this D it doesn't look good. So can you see what's 0, 1 D? So in this way, you will see which one runs good, which one doesn't. So for example, could you please open that file to see why it doesn't have a good example? Yeah, it's a little bit weird. Yeah. So it's 10. I'm not sure. So you have the hist.
Start from -8 up to 8.
Yeah. So more or less.
It's fluctuating.
It's quite flat. It's very, yeah, it's kind of range. Yeah, let's see. Let's go to another one to see which one is your good plot, right? I think you're in the four plots in your original. You will see there's one is good. Right? Let's see what's a good one. Right? Yeah.
I think
Yeah.
if I remember correctly,
Comment.
blue is the
Yeah.
good one.
Let's do the B, right? For example.
It is A.
You don't have to use to make the first 5 lines as comment. You only need to use the last ones, just to only put them on the figure or not.
Yeah, this one, they mean.
Yeah, yeah. This one looks, yeah, okay, that's right. So
This one is looking good, isn't it?
yeah, looks good. This one looks good. So it goes, it goes all the phase 1, right?
This one.
In general, it will have a double peak in general. Yeah. Let's see what's the other. The red line, you will see, maybe see. The M. Let's see. Let's look at the M. Yeah. Yeah. Red looks okay. So 1 and 2 looks good.
Okay.
Yeah. Why the 3? Let's see, let's look at the 3. The B. Yeah. Let's look at. Yeah, I think after that, all are not good.
All,
yeah.
Except one.
I think there's something. Yeah. Let's look at your log file. Is the system give some warning or is
where?
say is any error message during the running? Say this is a little bit weird. Yeah.
In Ubuntu, in the simulation running or in the Python running or where? It's a little bit weird. Why you get this one? I think compare Doctor with this one, the same.
Yeah, I think you get 1 and 2 are good, but all the rest are not good, right? So from
as this one, Doctor, all the rest are not good, but only 2.
Doctor, I believe whenever we exceed CDAT 4, we all got the same issue that we are not having a peak, even in the tutorial. So from 4 and more, we're not having that. I don't know it's an issue or not, but this is what we are all facing.
all right.
No, it should just go become more uniform. So it's normal to have no peak, to be more straight.
Yeah, I think let's think what's the issue here. That's the issue here. Could you please send me your simulation results, and I will run your I will do a little bit of debugging, all right, from my side. But please keep thinking about yours too, right? So
these files, you mean,
Doctor? Yeah. So let's see how many max, all right? How many? How big of your simulation?
So should I plot all of them?
Yeah. If you go to from your directory, you will see how many sites. All right. Otherwise, if you're small, you can send me by email. Otherwise, you may just send me the link in the server. You can upload it to the server if you like.
I think I'll send you by email.
Okay, okay. Please send me by email and have a look. All right. I think the other one, other students, if you like, you send me and see what's
Yes.
the reason. Yeah, because
Yeah.
maybe the first one or two are good, but for the rest, you goes to do not do the sampling very good. So I just I need to find out. All right.
Doctor,
Yeah.
is there any calculations after finding the figures? Because in the class you said something about the error and finding G and things like that. But do we have any calculations after finding the figures?
What means finding the figures?
So the figures for each step, the bias and visits for each phase. Do we have any calculations after finishing the figures?
I'm not sure I understand your question. So you have you have the different figures and it's difficult to find, or what's the?
No. I found all the figures, okay, but I'm not sure. Is there anything else to do in the project to be written in the report?
Okay, in the report, actually, I just want you guys to find have these plots, and then eventually later the final is find the difference, the free energy difference, right? Then you can tell the solid conclusion which phase is more stable. Yeah, that's the main conclusion. I hope you guys get in the report. As I mentioned in the lecture, so you just do the 1 points. Eventually, if you do the real project, you need to do many points. Then you will have a phase diagram, etc. So this one just have one temperature, pressure, 1 point. Yeah. So if you report the phase, the energy difference in that point is fine to me, right?
My energy difference
much
is zero.
burden.
I don't know. It's this. My energy difference is zero. I don't know it's right or not.
This should not be right. Yeah. Say
it should not be.
FCC, they should have different in the stability. Yeah.
So there should be a difference.
It should be different. Yeah. Because they have different. Pardon me?
Maybe I'm mistaking of how to find the difference. So if you could just tell us how to do it.
Yeah,
because I believe that I did it wrong.
Yeah, I think the difference, you follow the formula, right? In the lecture, we already give you the formula.
So how to find G to use it in the formula?
So we do not directly calculate the G. We calculate the probability. Eventually, is the time, right? So how many visits. So the visits, the time of the visits gives the results. Yeah. This is my lecture, right? Just go back, go down. Yeah, go down a little bit.
Doctor, do you mean the proper ratio step, the last one?
Yeah, productions, then you have the simulation, then you use the script, right? So you use unbiased, all of you will have these plots. So unbiased, the history, yeah, then go down, you will see the product simulation, yeah, you go up a little bit, yeah, go up. Yeah, so you will see the difference in G in the free energy is actually your probability, right? So we apply that probability ratio, right? So you get the probability ratio P1 over P2 from your simulation. Then from that, you calculate the difference. All right. So the delta G is proportional. I think there's a formula at maybe in the other slides. It will give you the relationship delta G versus P1 and P2. Then you do the calculation. Use that.
But Doctor, how to find G? So
No.
do we use?
Okay. Yeah. Please go. I remember. If please go up a little bit. Go up. Go up. Go up. Yeah. Even upper. Go up at the beginning. I think. Yeah. Wait 1 second. Yeah. Go up. Go up. Go up. A little. Wait a second. Go down a little bit. One slide. Yeah. Yeah. You will see this, right? The formula here. You do not need to calculate G1 and G2. You just calculate the delta G, the differences. The difference is the formula, right? We already have the T, right? KB is a constant, right? And we already have the P1 over P2 from our simulation. Then you can calculate the delta G, right?
How can we find P1 over P2?
All right, so from go down, so you just stopped, so you will see, all right, there's a script, right? It calls unbiased hist probable ratio. You will see from that file you get the P1 over P2. It's clear?
Okay, I got it.
Yeah, you should use that script to get P1 and P2. Then you can straightforward to calculate the delta G. Right?
So do we use this script for each phase that we calculated or not?
No, this is just for step 3, right?
Yes.
Yeah.
Okay, so
once you get the delta G, you will see you will get divided by n. Then the number, but this n is almost constant. All right. Yeah. So you will find that and do the discussion about that. It's central. So all of you almost be there. Yeah.
Got it. Thank you, Doctor.
Doctor,
thanks for your question. Yeah, please.
Can you explain the last slide? I didn't know what does it mean. Is it the same thing that you are explaining right now? The last slide.
What means last slide? Could you please?
Slide number 42, I mean.
42, okay.
Yeah. This one, what does this code do and where do we write it? In Ubuntu?
No, this one, from here, you will see the script probable ratio. This one, it will gives the P1 over P2 already, right? So from the P1 over P2, you just follow that formula. You can calculate the delta G, right?
Okay, I got it right now.
Yeah. So this one already give you the number. So you already, So this one you will see there's no technical difficulties. All of you, I think eventually from your parameter, each of you have different parameters, so you will have different P1 over P2. So you will see you have this delta G, you will have the delta G. Some of you maybe have a larger, some of you have a smaller, then you will see. I'm not sure it will be reversed because previously someone reported 0. I'm quite doubt about that, right? In general, it will not change the order. Because I use the low temperature and the low pressure. In general, it should not switch the order, right?
Okay, so this is to get P1 over P2, or we can do the method you said just now before me, right?
I'm not quite get your.
So there are two methods to get P1 over P2, right? This one and the other slide.
Yeah, you will see there are two methods. One is unbiased. Another is probable ratio. I think this one is there are two. One is biased, one is not unbiased. Right? You will see.
Okay.
Yeah, you can check the difference. Actually, I have not have a deep look about that. Yeah.
Okay. Thank you.
Yeah, yeah, yeah. You can do a little bit discuss about that even in your report. I'll give you some of your a little bit of freedom, all right? If you guys can do better. So you will see last time even project one of the students to calculate what's the effect of your take the density of the points, right? Sometimes you use large steps, sometimes you use small steps. What's the difference? So I really appreciate sometimes you show your creation. Say, okay, under this task, I find something new. That's always something something good. Right?
Doctor.
Yes, please.
I will stop sharing. Okay. I have finished my question.
So sorry, I got chopped. So what's your question again? Sorry.
No, I mean I will stop sharing because my question I have asked you and you answered and everything is fine.
Yes, sharing. Yes, this is okay. Yeah, okay. You can safely quit. Yeah. Any other questions? I think I'm almost the end of the session, but yeah,
Doctor,
please.
When I plot the unbiased, so all the previous plots I get okay, but when I plot the unbiased, it seems to be empty. I don't know why. Do we extract it the same way we do the rest? So like strip, YAML and all that.
So what's your question again? Sorry, I just did not get.
So how do we extract the unbiased? Is it the same way as the order parameter, for example?
Yeah, because we do the biased and unbiased. All right. We have two ways to do that. Right. But in general, I hope you do just from the BIOS, from that results. I think this BIOS is more efficient, right? The BIOS one is more efficient. The results should be the same. The results should be the same.
I mean, the last plot we asked for is the unbiased with the clear peak, right?
Yeah. The slides, you will see the unbiased, and there are also one just biased. So so you can test. You can do the testing. They will give you the similar results, right? They will give you similar results. For the unbiased one, that take a longer time because it's inefficient, right? Take a little bit longer time. But the biased one is more efficient, right?
But the
results should be the same. Yeah.
The unbiased graph doesn't work. The plot doesn't come out. So if do we extract it the same way we do, for example, the order parameter, just strip YAML SH and we write unbiased? Because when I did that to get the strip and I tried to plot it, I get an empty plot. I don't get a plot. The rest of the plots work fine. I don't know why. Yeah, the rest plot doesn't work.
Could you please share your screen? Let me see. Okay. Have a look.
Oh. So so I extract it like that, yes. Do you see my screen now? Yeah.
Yeah, I can see your screen. Yes, yes.
So this is the command to extract it, right?
I don't. Let me have a look. I can't remember this part now. Yeah. So do you have any? Yeah. Do you do LS? Can you do LS? Yeah. Let's see unbiased. Yeah. So you'll do the unbiased ones. Yes.
Yeah. But then, when I come here and plot it, I get nothing. It's empty.
Okay. Could you please do VI to see what's the data inside?
in BIOS.
Yeah, VI the file, right? You just open the file, VI and the BIOS, yeah. Double click. I think I'm afraid it's empty. This quite unclear.
I don't, because the other plots are all good. Here are they are all
No,
good. They are all working.
you don't need to write script.
Sorry.
I sent to chat. Only this word you have to write, then you will be fine.
So I just write unbiased. That's it.
Yeah, without VI. No. I send it to chat.
Okay, yes. In the chatting zone, the file
Like
is not in the chatting zone. Could you please go to the chatting? Yeah.
Okay, sorry. When I don't know, it doesn't go back to this one.
Okay. In your command line, you just the same as previous. Then you just do the sh. Then should be fine.
Yeah.
So like this one.
No. Delete. Yeah. Then dot. Then sh. Yeah.
Let's see. Okay, thank you.
Wow. Okay. Very cool. Thank you very much. Wow.
Thank you.
So happy. Yeah, beautiful plot. Thank you. Yeah, I really appreciate. You see, yeah, really appreciate.
Okay, thank you.
Yeah, I think all of you we are doing a good one. Please be flexible. All right. Yeah, I just originally already extended the deadline to 12. So I hope you guys do not be panic, all right, at the last moment. Please spend time a little bit. Also, you can use my server to do calculations. It's fine, save your notebook a little bit. I was told that if you use your own notebook to do the calculation, sometimes it will take you about 10 hours for the calculation. So just keep that in mind, right? The trick, all right, the two tricks, right? Currently you will see. The trick one, you will do the step one, you'll find the right range of your order parameters, right? You need to do a little bit of check your simulation goes to equilibrated and good range of your order parameters. Then you use that range of parameters, go to step two, you do the BIOS, the simulation. Then you go to step three. You should be fine for that. Yeah. The trick two is the input file in the tutorials. It's inconsistent from each other, right? You need to find the correct one is in example output, right? They have tested. That one is correct. You will see the difference. Yeah. Then you're based on that to change your parameters, right? Yeah, that's two tricks. Keep that in mind. Yeah. All right, I think it's almost the end of the session. If you have further questions, we can continue on the Telegram. And if less sorry or most likely, I will give another help session. So all of you got full scores, right, in the project 3, right? All of you got good scores, right? Thank you very much for your attention and have a good weekend.
Thank you, Doctor.
Yeah, thank you. Yeah, thanks. Bye-bye.